Programming paradigms are essential to computer science as they outline the way code is styled and written. When I was younger, I thought the object-oriented programming was the only right way to code, and Java was the best language. So obviously, I wasn't the brightest back then. I realized constricting myself to one paradigm wasn't a smart decision, and expanding my options could greatly increase my coding quality. I'm going to mainly focus on the object-oriented and functional paradigms, as OOP is arguably the most used paradigm, and functional programming is also growing rapidly in popularity. While coding, there's multiple ways to solve a problem, making the debate of which paradigm is the best useless. The idea behind object-oriented programming is to rely on the concepts of classes and objects, where a class could be considered a blueprint to instantiate objects. Classes usually represent a broad category such as cars, animals, or any other encompassing field. For example, if we have a class food with attributes supply and type, we can now create as many objects of food as we like. To add some more functionality, the class food can have methods. Most classes are even more powerful than they look like, as they can be extended from to make more subclasses. Here, KitKat can extend from food. With KitKat, everything is the same except the consume function is overridden. While this specific example is extremely simple, an object-oriented design allows for flexible code reuse. Object-oriented programming can be made more robust with features like abstract classes, interfaces, virtual functions, multiple inheritance, and more, but that's beyond the scope of this video. Something you'll probably hear a lot related to object-oriented programming are its four pillars. These are inheritance, polymorphism, encapsulation, and abstraction. Inheritance is what I mentioned earlier about KitKat extending food. KitKats are still a type of food, so they should be able to take all the properties of food. Encapsulation allows classes to manage how they hide data, allowing access through either the class itself or a function. For example, if we have a class for a person, we wouldn't want their address or SSN to be public. Otherwise, any other class would be able to access and potentially change those properties. On the flip side, something like your name could be public, as that data isn't as sensitive. The best practice is to declare any variables as private so nothing outside the class can affect it, unless it needs to be public. Abstraction is similar to encapsulation, however, it's less about data safety, but rather for ease of use. If we have a string and we wanted to make it lowercase, we can just call the toLowercase function, as we don't need to know exactly how the string will be made into lowercase. Polymorphism is also similar to inheritance, except it's about modifying behavior rather than taking properties. In my earlier example, polymorphism is used when we override the consume function. Object-oriented programming is not perfect, and it has its issues. First of all, the code made with object-oriented patterns will generally be longer than other styles. There's just more boilerplate code to write, and if the project doesn't need all the boilerplate, there will be a lot of extra unnecessary code. That's where functional programming can come in. I apologize in advance if I get something wrong with functional programming, as I don't have a great deal of experience in it. That being said, reading and writing well-written functional programs feel great, as they can be extremely elegant. The main idea with functional programming is that we use functions as our primary building block, as opposed to classes and objects. The functions are usually pure functions, avoiding shared state, mutable data, and side effects. For example, if we have a function that adds two variables and changes a global variable to the sum, this would not be a functional programming concept, as we introduced a side effect. The side effect was caused by altering a piece of data beyond our scope, which is the function. Side effects are something developers avoid, as they can cause bugs that are completely unexpected. We can make the function pure by not altering the global variable. Another concept of functional programming is that data is immutable, because mutable data can also cause side effects. Instead of having shared state and mutable data, we can alter data by using other functions such as map. All map does is run a function on every element of an iterable. In this case, we just append a fire emoji to the end of each string. Map is also an example of a higher order function, as it's a function that takes another function as a parameter. Functional programming has many benefits that object-oriented programming doesn't have. You can get these beautiful or ugly one-liners depending on how you like your code to look. It's also far easier to track down bugs, as a bug should only be contained within one function and won't have you jumping through 10 different files and nested objects. Although functional programming seems like a developer's dream with smaller projects, it can be considerably harder to scale up in certain cases. This is because modeling a problem with functional programming is not as easy as it is in object-oriented programming. For example, take a car that needs maintenance on a certain date. In this case, we can just have a car object with an attribute for when it needs maintenance. In a functional approach, as there is no state, we would have to use a function to find out if the car needs maintenance. I'm not sure if that's the best way to do it, but if there's other methods, feel free to comment them down below, as I would love to know about them. As you can see, both these paradigms, just like every other paradigm, have their benefits, but also a wide variety of issues. I read something on Stack Overflow along the lines of object orientation can improve with functional programming, and I agree. Not everything has to be the same, however, the functions can improve. Methods can take the principles behind functional programming functions. They don't need to have zero side effects, however, minimizing them would be extremely helpful for debugging. The longer object-oriented code can also be split up into sub-methods to do smaller tasks. And since object orientation allows abstraction and encapsulation, the end user doesn't need to see those changes. Wherever applicable, the one-liners and more concise code patterns from functional programming can be used to create elegant code. Mixing paradigms and code patterns can increase code quality in so many situations. Multi-paradigm languages are on the rise and are here to stay. It's better to embrace the multi-paradigm approach rather than to bottleneck your code by sticking to only one. As with any choice, there's going to be pros, but there's also going to be cons. You might as well take the best from all paradigms and work off of that. Thanks for watching. I'll see you guys next time.